Okay, hi everyone. My name is Chima. It's been a while. We had one of these sessions where I just rant about things we are actively working on for Globe, things I'm doing in open source, and things like that. Today, I want to stream about this thing we've been exploring. It's an R&D project that actually ended up working in the end. Pretty exciting stuff. But then the whole idea is to build a bridge which allows us to run JavaScript modules from that. And the thing is, why would you want to do something like that? Yeah. So if you probably haven't seen this blog post already, this was published, I think, on 8th May. That was Wednesday, I think, or Thursday. I don't know. Yeah, and then the whole idea is that that is good but early, and the reason it is early is because a lot of libraries that exist in other ecosystems like JavaScript and these other programming languages, you come to that and then you see that it's like a baby, not a baby language, but then it's pretty early. It doesn't really have much of the libraries that you'd find in the other ecosystem. So what can we do? It's either we have a whole bunch of companies out here that are going to invest heavily into building open source packages, and at the cost of that, you have to maintain it. It's going to take time. It's going to have a lot of bugs until a certain point where it becomes really stable. So what can we do? What if we could reuse the work that has already been done in other ecosystems, but then run it in such a way that it is native to our language, which is Dart? So how do you achieve that? So the first thing is what kind of JavaScript code are we trying to run? Is it just a few JavaScript snippets, or like you want to run a full-blown module? Let's say you want to take a Node.js project or a Node.js library and then run that. There's a whole bunch of things we need to think about, because first things, as you can see here, we have a module. And when you come to JavaScript, there are things you need to execute JavaScript, like you need an execution engine. There are lots of them out there. A popular one from Google is called the V8. And you go to V8, V8 can pass your JavaScript into actual objects that you can interact with. But then when you come to some common functions like fetch, exports, and all of these things, V8 really doesn't understand what those things mean. So you have to teach V8 what fetch means and all of these global objects that doesn't come out of the box with V8. So yeah, just a whole bunch of things you need to do to be able to execute JavaScript. And taking a look at that has FFI. We can call C functions, all these dynamic libraries. We can load them up and then call symbols and then expect some results. So if we can have a way to use V8 to run our JavaScript, and then in such a way that we can send the results or the responses or callbacks back to that, then we can have a system that is able to run modules. So in the blog post, you can see I have this we have this screenshot here of a module, export default, and then you have an init function, and then another key called functions, which just lists out a bunch of functions that can be called. And yeah, this is a module, and our Dart code or our runtime should be able to load that module and allow us to call those functions. So that's the point where we enter Dino, Rust, and V8. And what is Dino? So if you know JavaScript and you've played with it enough, you've probably seen Node.js. And Node.js is this runtime that uses V8 coupled with a bunch of C++ bindings to like the operating system features, so that we can have JavaScript code being able to interact with the hardware and network and IO and all of these things. So Dino is kind of like should I call it a rewrite of Node.js, or another practical approach to the whole JavaScript runtime that allows you to talk to the machine just out, not just limited to what the browser can do. So that is where we go to Dino. And the good thing about Dino is that Dino is written in Rust. It has a bunch of tooling that allows you to work with V8. And if you've actually played with V8 before, you know that there's just a whole bunch of things to know about V8, and there is some bit of documentation, but then not too much. And if you wanted a structured approach to working with V8, I think the work that the Dino team has done is pretty good. They kind of built a tooling around it. So yeah, that's why we chose Dino. It wasn't too far off from V8. You can access V8 itself outside of the Dino abstraction on top of it. So we used the Dino's runtime, but then not all of it, just bare minimum that's able to pass JavaScript and execute it. Just that, and then we built a portable JS runtime using Dino's tooling and V8 glue code. And here comes the interesting part where we have this package called Globe AI. It's a pretty new package that we are actively working on, and the whole idea of this is to bring the Vercel AI like features to Globe. I mean, to the Dart community, but then the idea is for it to work in Globe first, and then we can start exploring support for it outside of Globe. So you should be able to do things like, accessing all these modules. You can generate text. So things like this that exist in JavaScript, you can barely find them in Dart because somebody has to work on that. And it's going to take time and money. So you have generate text, you have the open AI, which you pass a module and then you pass a prompt to it, and then you expect a text result. Let me check if I'm still live. I don't want to just end up ranting the whole time. Okay, they're still live. So this is the idea. This is where the entire thinking came from. Like, how do we bring these features to Dart? You get? And not just bringing them, but then in a way that feels native to Dart, such that you don't have any new learning curve, like you need to call the function in a certain way. No, we wanted you to write that as that while we have this whole abstraction that uses JavaScript in the backend, which you don't have to know about. So getting back to the blog, we have this Dart package, which currently you can use locally. If you deploy this to Globe now, it won't work because we actually haven't added the support for it, but it can run locally. Just a matter of time before we add it to the Globe runtime. So you have this generate text, you pass the module, and then you pass the prompts, and then the result you get here is a string. And the blog goes on to explain that under the hood, this code is calling JavaScript's AI.generate text, which I showed you in here. You have this AI has generate text, and then we can call that. So that's basically what you're seeing here. That function call goes behind the scenes to call this JavaScript function through the runtime. We pass a bunch of arguments here, and then we make that call, and then we send the results back to that. And that's due to the runtime that we have. So yeah, now talking about how the whole runtime, the interface works. So the runtime itself is written in Rust, but then we have Dart bindings to it so that you can interact with the runtime from that. And it also has a JavaScript binding to it so that you can interact with the runtime from JavaScript. Now, going to talk about the Dart binding. There is a class called the JS runtime, which gives you an instance, and then with the instance, you can register a module. And a module is the JavaScript module, which we saw past. So you need your module name, you need the path to the module. It could be a local file or a remote resource. And then you have some arguments which you can pass that will be called in the init state of that module. So then the next thing is you have this function called call function. And that's simply to call a function that exists in your module. So as you can see here, we are calling the AI chat generate text. And it gives you a callback on data, which allows you to listen to whatever data that comes from that function call. You would get it in here. So when you're doing things like streaming, or you are just doing a function that needs to resolve to a value, you can control the execution of that flow. So like I said, you write JavaScript like JavaScript that sees it as a native SDK. Okay, so then the next thing we need to talk about is with this runtime, the one important thing we need to think about is how data is flowing from one place to the other. How is the data going to flow from that to JavaScript, and how is it going to flow back from JavaScript to that? And the easiest thing we could think about was this form of data packing thing called message pack. It allows you to serialize and deserialize data into bytes, and this worked for, like, it worked pretty well. But then one issue that we kept running into was that it was hard to maintain the let me say the contract between that and JavaScript. And what I mean by contract is you have a function that is returning a typed data. It has, like, let's say a name, an email, and a password, and it's an object, and we are returning this to that. Let's say we have two classes that represent this piece of data that we are sharing, and if, let's say, something should change on the JavaScript side of things, and then we send this data, then that is completely unaware of that change. So while passing it, it is going to break. So what can we fix around this? So we introduced protobufs, and what protobufs allows us to do is that it has a strict schema that allows us to define the structure of the data. So once we define that, then we can use the protobuf generator to generate the typed classes for that, and then also generate typed classes for the JavaScript TypeScript side of things. So no matter what happens, once we make a change to the schema and then we generate our code, we know that the contract is going to be still intact between the two programming languages or the two environments. So yeah, we still kept the message pack, because one thing we noticed with protobufs is that working with JSON type of data where you are not really sure what form the object is going to assume is just so hard to work with in protobufs. Maybe we would find some way to work around it, but then we still kept the message pack strictly for JSON type of data, and then we still kept the protobufs for function calls where you want to enforce some strict structure between your calls. So the next demonstration of that Globe AI package, which uses the runtime, is we being able to stream the AI responses. So you have this function called stream text, which we pass an OpenAI model, which uses the 04, and then we pass a prompt. And then you can see that we are awaiting each chunk in the stream, and then each chunk of that is just going to be like a string type data. So we write it to this buffer and then we print it out. Yeah, and so the last thing is what we gained: the time saved. We don't have to write SDKs like OpenAI and co in that, and also it future proofs that, let's say, language, because, like, as of now, I can find any Node.js package, and if I want to use that feature in that, I just have to write it as a module. I mean, install it as an npm package, write my module, and then I can use the runtime to execute that easily. All right, so I think I've been talking too much about the blog post. The runtime is open source, so you could actually just check the blog post and you find the link to that. I actually wanted to get into what a package that uses the runtime looks like. Before I proceed, let me just do a quick check and be sure we're still live. We're still actively live. Okay, so we actually worked on this Globe AI package really quickly because we wanted to test out. It was our MVP for the runtime. It was the one thing that would prove that the time we had spent on this runtime was actually worth it. And mind you, it took I think 5 months to get this up and running. So This is a Dart package like any other package. It has this generate text, and then you can see the file structure of this package. We have a globeai.typescript.ts, and it has a bunch of node imports. Yeah, so you can see we have a node module here. Don't get too scared. This is still Dart. This is not your typical JavaScript scenario. And we have this Globe AI package, and all of the implementation is inside this Globe AI base. Okay, so we will take it step by step. I would go into this bin file, and then I would run. Before that, let me add my OpenAI key to my environment variables, and then I would run bin globeai.stat. Okay. All right. So as you can see, it works. And what just happened? We got a warning. It says using local module from dist. Okay. So it is written in such a way that if you're developing, it uses the file from this dist folder. So this we won't talk about much, but what matters is what's happening behind this generate text. So when I go into that function and let's see what is happening, it says AI provider.get instance, and let's see what AI provider does. Okay, so don't get too scared. We have the module name and then the code URL, and we have this get instance. And okay, so we have the globe runtime, which is the JavaScript runtime we're talking about. So that's your entry into the runtime that we wrote. So you have to register the module like I mentioned earlier, and the module name is going to be Globe AI SDK, and the code URL is going to be a link to our JavaScript file. I mean, our JavaScript code that needs to be executed. And let me, I don't think I can open this because of this variable, but then it looks like something like this because the code has been bundled and made smaller. So it's just a whole mess around the place. But the actual file is this one. We have a global state, and then we have this thing, and then we have this arguments, and the JSON message pack thing I mentioned is happening here because we added it to the global scope. So we can just call this, let me do something here, console.log model arguments. And I will now run this again. Let me use npx. So as you can see there, our console.log worked. We got the argument instance was chat, and then the user was Chima, and we passed them to this guy here. So yeah, it's as easy as that. We make this call on the JavaScript side of things, and then we encode it into bytes, and then we send the result to that using this that.send value. So this is just a type definition. The implementation is inside of the runtime. So this is more like you add types to your project so that when you are running it, you don't get this red squiggly lines because your code can't find it. So it's as easy as that. So that's the module registration. And what happens next? After we register the module, after all of this is done, then we add a Dart completer here, and we get the module options that the person passed, and then this is where the source is. Call the function, call the JavaScript function. So this is just giving us access to the JavaScript runtime we have, and then we make the call function, which uses the module name, and then the function name, which is the open AI chat generate text, which as you can see here, we defined here, this one. So it goes to call this, and then we pass a bunch of arguments. So these are Dart types that need to be transformed to an FFI type that the runtime understands. and we, on our data callback, we check for a bunch of errors, or if it's no error, then we just complete the completer with the data which we got. And since it's a bunch of bytes, we can decode that back into a string using the utf8.decode function. And then we return our completer, which then gives us this future here. As easy as that. So let me try a scenario where the function doesn't exist. Let's say hello world. And let's see if things fall apart or it still works. Okay, so as you can see, this is an error that we got from the runtime. It says what, unhandled exception, function open AI chat generate text hello world not found. And that's because the runtime tried to call that function, but then it found that the function doesn't exist. So yeah, let me see. Okay, so another interesting use case which we were able to do is if you use AI and all these new shiny toys, you know that you can generate like objects with AI if you're able to give it a schema that it can use as a lookup. So we were able to make something like that work. Let me see. Okay, so the interesting thing is this uses a schema validation library from one engineer. So we have the schema saying the recipe, and the recipe has a name and then ingredients, and each ingredient has a name and an amount, and then the steps, which is just a bunch of strings. And we say generate object, we pass a module, and then we pass a prompt. It says generate a recipe, and then we pass the schema to it. And let's see what happens. Okay, so as you can see, it's worked. And this is a map dynamic type. I mean, in actual fact, it should be string, but you would have to do that cast, or you have to do a map. You have to do from, which we don't want to do. We're just interested in the result. So as you can see, that worked. And when we go into the generate object, you can see it makes a call to OpenAI chat generate object, passing arguments as usual, and then it overrides this on data callback. And yeah, the type here is whatever you pass here. So that's a map dynamic type. Let's see the JavaScript side of things and see what that information looks like. So we call generate objects, which is from that OpenAI package, and then we pass the schema is converted into a Zod schema. If you know Zod, we convert that into a Zod schema, and then we pass it here, and then the result, since it's a bunch of JSON data, which we are not too sure what the form is, like we don't know any idea about the form. Everything is constructed at runtime. The safest way to deal with this data is to JSON encode it. And to just do that, we don't want to do something like JSON.stringify, like something like this. No, we don't want to do this. We want to use the message pack, which is already part of the runtime, to do that. And the way you get around that is by using the JSON payload, which is added into the global scope for you. I mean, the implementation and everything is in the runtime, so you call JSON payload.encode, and then we pass the result from here. And if this doesn't work, then just send this error, or we send the value back to that. Yeah, so pretty much that is the runtime, and Globe AI package is just one of the ways we are currently using it. All of this code is open source. Let me get into my browser, Globe runtime. And there's not yet any documentation for the runtime, so If you needed to see what is possible, then means you have to refer to that Globe AI package, or you can look into the Globe runtime dart package, which should give you all of the runtime details, what is possible. This is just a bunch of FFI stuff, so nothing too crazy. You can get the version of the runtime, you can dispose it, you can call functions, and then you can register modules, and you can check if the module is already registered. And that's pretty much it. Let me Globe AI example. Okay, so this project is actually also open source, the Globe AI example, which you can run yourself. It's a tiny shelf project that uses the Globe AI package to demonstrate how this runtime works. So I think I would add a link for this to the live stream. You can go check this out. And yeah, if you do have any questions, just ping me, just at me directly. I'd love to take feedbacks and any bug reports. And yeah, it's been a while. My my battery charger for the actual camera is spoiled, so today I just had to do a bare minimum setup, no microphones, just using my Mac. So apologies if the audio is shit. But yeah, hopefully it's getting fixed soon. And that's Globe runtime for you, being able to run JavaScript modules from that and all of that stuff. So yeah, till we catch up again, do have a nice weekend, and yeah,